Hello, everyone. Wow. Very good morning from Germany. Hello, Jameson.
Very good morning. Actually, should I say good afternoon from Singapore?
Yeah, you must say good afternoon. This is right. This is right. Yeah, we would like to welcome every one of you and thank you for signing up. I think we had 70 plus people now signing up here in this session. So um, this is the final session out of, I think, 4 rounds, Jemson. We started our webinar series with a general introduction of sample handling systems for SEMS, continuous emission monitoring, and process analytical technology solutions. Then we had, I think, the first more specific session with gas sampling probes, primary probe sampling. Gas transportation was the last one, and now we are ending up as gas or sample conditioning systems. And again, Jimson, I think that's a very successful time if we look back. I think we had more than 300 people. No, it's even must be even 400 people in total who joined our sessions here, and it's just great to see. And I want to thank you, Jimson, also for your support in this. Okay. Yeah, as you can see, I have a friend standing next to me, a friend, so to say. Actually, it's two. I wanted to show you, and this, by the way, has only started. I just plugged it in 2 minutes ago, so it already reaches 3 degrees outlet dew point, which is very nice to share and to show. Let's start here with a general introduction to get everyone on board and to explain what is the guy standing next to me making some noise really about. And yeah, Jimson, if we look at the today's agenda, I think that gives a pretty good overview what we have now gone through. Let's first of all say hello to our dear friend Jose from Dubai. I saw he gave a message here. Jose, great to have you also here on board. I know that we have many people also joining from the Middle East, obviously from Asia, some from Europe. And the US is still sleeping at this time, so obviously this is. But sometimes it's crazy that our dear colleague Antonio Mena from Brazil is even joining. But for him it's in the middle of the night, so I think we can understand that they are still kind of sleeping. Yeah, Jemson, I mean, when we have a look at this overview here with the gas sampling probes, the heated sample lines or the tube bundles as extruded and as flags, and the conditioning system, I think all of this unites one of your main sentence is that there is not only the one sampling system,
Mhm.
and this is also the reason why we have such a high variety of different products fitting exactly to the right solution, to the right application, right? I think this is the reason why there is not only just a single version of this. Um, I think once you said, Jimson, the cooler is kind of the heart of the sampling of the gas conditioning system. What do you mean by
Absolutely,
this?
absolutely. Yeah, yeah. I always, in the design of the gas sampling systems, the gas cooler, I always say that either you get a weak heart, a strong heart, or you may experience a heart attack.
Okay.
because yeah, starting from the probe, the gas transport line, and now that the dryer. And I like to say one thing, all the things that we say, let's put the technology aside. We really talk about the material, the materials that we engineer, whether it is a housing or whether it's a filter or whether it's an analytical PTFE or whether the material of the heating cable. And now we comes back to the cooler, which is again, we're talking about the hypophoric exchanger, all right? And therefore, this, you know, why there is a cooler that is so much different in terms of performance, and we have so many models in our family, the cooling family. Yeah, I hope this webinar we're able to enlighten different options of the cooler and then combine with a new product, right? Where we're gonna share it in a short while. Yeah,
That's true.
back.
That's true, Jensen. And I think pretty good fitting to what you just said is the overview of the PSG product strategy, because we have a basic product line for, yeah, more or less standard application, for a SEMS application, for example. Then we have the field of plus, which brings us to, yeah, solution we can individualize a lot, which might have different performances, might address niche applications. And then finally, we have the process product strategy or product category, which is then clearly for ATEX or IECX solutions. So basic, plus, and process. Why did we set up this product strategy? Because we thought, okay, somehow there has to be a sorting of the different areas. Like you said, Jimson, there's so many different solutions out there from us. And yeah, I think that should give a pretty good overview. Now, Jimson, help us to understand. I mean, many people might have seen already the first webinars and have seen the overview as well. But Jimson, help us to walk us through the PNID here and explain maybe the relevancy, as you said, for the why you said the heart of the sample handling systems.
Yeah. So, uh, you see, starting from the probe, it is the only component that expose to the sample: water, dust, temperature, acid, all kinds of exposure, different industries. I call it like an arm, to do the measuring. And then we have a moving sample transportation from the probe to the cooler. It's like our legs, all right? And then how strong and how fast and all this has to take it into consideration. And lastly, the heart of the sample conditioning system is because it is really a technology of how do you call a cooler and regard it as a good cooler. So in order to have a strong heart, we can continue talking about variations, features, benefits, technology, but there's only one thing that we can say that is a very strong heart, is to have a reliable, stable outlet dew point. Because when we sell it to the system integrator, we have no control on how they design the sampling system, how much water is coming in, how fast the flow, the pump is, and how fast is the flow meter. All right. So therefore, all this, in order to give a stable analyzer measurement, the dew point, whether it's calibration, whether it's sampling, the outlet dew point must able to cater for the changes in the inlet so that the outlets always remain stable, all right, which is
Yeah.
always at 3 degree C.
Yeah. Yeah, I think that's a very good description. Um, I mean, we must say, coming back to this PNID here, Jemsen, is not. I mean, as we said, there's not only the one and only sample handling system. That also means there's not the only or the one and only PNID. That means depending on the analyzer technology, depending on the application we are measuring, the PNID looks different. And I think it's also fair to say that there might be some analyzer technologies where a cooler, or I like to call it a dryer, is not needed, right? This is something we have to keep in mind. So, Jemsen, in general, from your experience, I mean, there's the one category analyzer system we talk about. This is the hot wet, and the other world we are discussing is the cold dry. Maybe you can explain a little bit from the sample handling system, what is the difference, and also from the analyzer technology.
Absolutely. You see, many of our partners ask these questions. Why PSG has such a big family of gas cooler? Okay, yeah. I think the most important that in the gas cooler that we are considering to answer your question, York, is about hot, wet, and cold, dry. Is really about we address the solubility of the gases. If the gas is dissolved or washed out during the gas cooling, all right, and we are going to measure this gas that, so therefore we choose to have a hot wet without a gas cooler. For a standard SAM systems, right, for standard SAM system like COO2, SO2, NOx, oxygen, a cold dry is the most economical, easiest to maintain, and it's very easy for the system integrator who is doing it. So therefore, we use a cooler, right? There are gases whereby you need to measure HCl, HF, NH3, which is ammonia. All right, these are very easily washed out. In that case, we will choose a hot wet analyzers. All right. So for the
So hot
audience,
wet, hot wet analyzer then, Jemsen, means you still need a heated filter. That means the gas sampling probe, the GSP, has to be heated for sure. Then you have a heated sample line, yeah, connected to the gas sampling probe, but then the sample itself can arrive hot directly to the analyzer.
yeah, including a hot pump. Yeah. In fact, it is in our portfolio. For the hot wet, normally we can choose the thermostat control. But for the sorry, let me correct. For the cold dry, we can easily choose the thermostat control, 180
Yeah,
degrees. Yeah.
yeah,
For the hot wet, many a times, right, for according to the TUV certification, the temperature that they manage or control is 191. In this case, you have to choose a component combined with our temperature controller, all right,
okay,
that we are able to manage at 190 or even 91
okay,
precision.
okay. But as you said, cold dry systems are still a very big part of the analyzer systems. As you said, these multi-gas component systems like FDAR, the hot wet solutions, there are some applications where they are almost over the top, right? If you just have to measure, let's say, maybe three components or the three main components, CO, SO2, NO, then you would prefer maybe to go for a cold dry system, right? And
Yeah, yeah, yeah,
so in these cases, it applies that you need to have a sample gas cooler. And like I said, in the meantime, I'm switching this a little bit in our wording. Um, I mean, it is cooling. We have a compressor running here for these two guys standing next to me. But this is just the way it works. This is not the description of what this component has to do. It has to dry the gas. Okay. So, Jemison, if we talk about not only the vapor share, but also regarding the volume flow, what can you tell us about that to give a little bit the theory and the background of the sample gas cooler?
yeah. So you see, uh, a most common system integrator which I watch is the heated sample line. The connections between the heated sample line into the gas cooler.
Okay.
Yeah. Bear in mind that gas is different from water. Yeah. We have the condensation of water can easily takes place in
Yeah.
yeah in because the ability of air or the gas holding the temperature is rather weak. So therefore, many a times I saw that the heated line, when they enter the analyzer cabinet, they have a length of unheated sample PTFE tube that goes into the gas cooler as much as a 1 meter length. All right. In this diagram, as you can see, that the holding of this dew point to maintain the sample in a gas phase, there is a high possibility of losing, and it becomes condensation will already take place in the tubing.
Okay.
Therefore, I like to say to all of the audience, it's like the rule of thumb that the heated line that enters the gas cooler keep a distance of unheated 20 centimeter. If whether the cooler is PTFE,
Okay, so that goes for the direct cooler, the connection of the heated line, where the heated line ends, let's say, to the sample gas cooler, you would say make a piece of 20 centimeter of unheated line. So the heated
yes,
line should not be directly connected to the sample gas cooler.
yeah, keep it
Okay.
this 20 centimeter, everything will goes right.
Okay. Good. Yeah, Jimson, now I think I can jump in a little bit because, I'm pretty proud of what we have developed there over the years. I mean, I think it's well known that the cooler business is not from PSG originally. It came from the acquisition of the company AGT. AGT, by the way, is one of the oldest and, I would also say most reliable producer of gas sampling coolers because, they have developed at very, very early stage. And I think, we have a huge installed base all over the world. But from the acquisition in 2016, we directly started to develop a new heat exchanger system. And I think it's important to explain, Jemson, why is the heat exchanger such a big topic in this kind of equipment?
Wow, I think this is a very interesting questions, right? When I'm selling the promoting the gas cooler, again it goes back to the inlet dew point and outlet dew point. In the entire gas sampling for emission monitoring, when we want to regard a robust sampling system, why the probe is 180 degrees, why the heated line 180 degrees, why the cooler is 3 degrees, we only address one thing, is dew point, just a dew point. Therefore, having a dew point, all right, is combined with the washout of some certain gases, combined with the T90, the response time, especially for calibration, and combined with right with all these three together, dew point, washout, and T90, and that goes into, we classify two family. One family we call it the emission monitoring cooler, and another one is process cooler.
Yeah,
Yeah,
that is a good way, Jimson, and I want to thank you for this. Yeah, I think this is very important to all the listeners and the followers out there. So, a cooler is always kind of a compromise, not a bad compromise, but I think you outlined exactly the most important points there, Jimson, the criteria to select a cooler. So as you said, first of all, I think this is basis for any cooler device, for any selection device. We need a low and constant outlet dew point. And what sounds relatively easy is in practical sometimes a big challenge. Currently, we have a very big cooler project in hand, and the ambient temperature, Jemson, is not only 45 or 50 degrees, but the equipment has to be selected to 55 degrees even. Okay, what does it mean? That means with a very high ambient, we have to make sure that the outlet dew point, which at the end represents the remaining water concentration, is constant and low, because all of the following process will adjust to this, right? Now,
yeah,
from a technical point of view, you would say, okay, if we need a constant and low outlet dew point, we put a lot of cooling capacity or cooling energy to the sample we want to dry. But unluckily, this is not so easy, because if you dry the sample, the gas you want to measure, too strong at the very beginning, this will then result in very high so-called washout rates. And Jimson, as you say, I mean, we are always measuring SO2 as this component has a very high washout, but also other components like NO2 or HCl, NH3 obviously have a problem if you have a high washout rate. So this means, or this is the reason why the design of a heat exchanger is so critical, because you have to define the circumstances and you have to define the surrounding parameter. And therefore the development of such a device is a big effort, and we are very happy with the MAK20 with the jet stream to develop a system which is, I would say, a benchmark or on a very high scale as a super compromise, also including the T90 time.
I'd like to add one more point.
Yes, please.
Yeah, I think the Mark 20, one of the really strong point is about our PVDF material. And I want to tell the audience that today, the technology of this surface, of this hyperforic surface, so smooth, right? Although you can say that it's a PVDF, but it is already so smooth like a glass. it is so effective in to minimize the washout. This is one of the key features of our exchanger. Not only that, it can be removed and washed. This is something
Okay.
that is very good for the maintenance personnel.
Yeah.
Yeah.
Yeah, that's a very good addition to this, James. Okay, now let's again, we are kind of running out of time. I think in general, I would start with this heat exchanger overview. Um, how to dry the sample. I think there's one principle which we called the jet stream principle, as you can see this also here. So this is the heat exchanger inserted into the cooling circuit. And the other one is so-called coil heat exchanger with different functionalities. I think we will also talk about the BCR when we have an outlook on the process cooler. But the let's say the last category will be membrane or maybe Nafion technologies. I think, Jemsen, you should explain a little bit the background of this technology.
Yeah. So the Nafion, right, can be incorporated together with our sampling system. Many a times we have an application where we are facing the high SO3, the high SO3. So how are we going to address the high dew point of SO3, which is an interference and also a contaminants in the measurement? In the market, basically you have two choice. Choice number one, you have a deep cooler, which has a dew point of minus 300 degrees, which going to cost you a
Minus
bomb
20,
for
minus
minus
20
20.
degrees.
All right,
Yeah.
we're causing you a very expensive. Another option, all right, is that you can have our standard cooler. At the downstream, you add a membrane dryer, and you're able to bring the dew point of the sample, all right, below the SO3. Therefore, it actually eliminates the corrosion and also, the interference in your measurement. Of course,
Yeah.
the Nafion to work, you need to have a dry instrument air, all right, to pair them together.
Yeah.
Yeah.
Yeah, that is required. Thank you, Jimson, for this overview. Um, Now, Jimson, you said we talked about SEMS cooler quite a lot. I think now it's important to also show the varieties and the solution we have here in PSG with the so-called process cooler. Maybe you can say some words, and I'm going to show the BCR cooler here.
Yes, yes. This is always the same questions coming from my customers. When are we going to choose the BCR instead of the Mark family? The answer is like this. The BCR is able to take positive pressure. All right. So many a times the Mark family, all right, they are for emission monitoring. They need a sample pump, and it is measuring the sample is in the negative pressure. But in the process is clean, all right, and the process is normally a positive.
Yeah,
And for that reason, depends on the how positive is the pressure. You can either use a peristaltic pump or you can use a auto drainer, which is part
yeah.
of our supply.
Yeah, I think very good, explanation here, Jemson. So yeah, again, if you, like you said, it's not only the positive pressure, it is also the positive pressure because we have stainless steel heat exchanger here. But the difference is also that we can cool even if it comes for very fast measurements. We have heat exchanger technologies where we can dry super high flow. And if I think the beauty is what we can offer from PSG, and this is what we explain with a perfect sample gas solution. We can not only give you a good advice in compressor or Peltier cooler, thermoelectric cooler, something we haven't stressed here too long, but also on the Nafion dryer. So the company we are representing there is called Permapure, not anymore. Zelera is the new brand name of them, but I think Permapure is very well known. And we can help you to design and support the design of your sample handling system. And I hope we were able to show you the possibilities we can offer here, starting from the primary probe sampling, going over the heated sample line, meaning the sample transportation, and now finishing kind of in this field for sample conditioning. Let me just also show, Jemison, there's a lot of more components you might need. Some components we can offer as an option, that means integrated into the sample cooler. And also this overview really shows that there's many different ways how we can support the design of your sampling system, and we would be very happy to do so. So, as we are coming to an end on this webinar series, I want to thank you all. Reach out to our world team. Jemison, you have clearly seen that we have a new business development director, Tim, who joined us recently, building up the perfect sample gas way to the US, something we are very excited about. And please also reach out to our team we want to thank you for your time. We want to thank you for your attention. And Jemison, I want to thank you personally for doing this here together with me. Yeah?
It's my pleasure,
Thank you very
sir.
much, and take good care. Bye-bye.